You know, as IT pros, we love to focus on what we can see and control, right? We're all about server stats, patching firewalls, and optimizing networks. But what if the biggest threats to our systems aren't digital at all? What if they're invisible forces that can take down the very infrastructure everything else depends on? Today, we're looking past the server rack at these hidden dangers. Welcome back. This is part 3 of our 10-part deep dive. We're pulling all this from a fantastic report called An Introduction to Radio Frequency Interference, or RFI, Electromagnetic Interference, or EMI, and Space Weather for IT Professionals, which was put together by the RFI detectives over at Virtualization Options LLC. Now we get to move from the theory into some pretty critical real-world stuff. So if you're just joining us, honestly, you're hopping in at a great time. So let me just ask you this. You've got your servers humming along, you've got redundant power supplies, maybe a top-of-the-line UPS system. But what happens when the problem isn't inside your building? What happens when the power grid itself starts to get noisy and unstable? This is where a small IT problem can blow up into something much, much bigger. And that's really our whole focus today. It's about expanding how we think about IT resilience. We have to start considering the physical world that our digital systems live in and really understanding that our job doesn't just stop at the server rack anymore. Okay, just as a super quick refresher from last time, remember the main difference here. EMI, or electromagnetic interference, is the big umbrella for any kind of electrical disturbance. That includes conducted interference, which is basically noise traveling down power cables. RFI, or radio frequency interference, is just a specific slice of that pie. It's the interference that travels through the air as radio waves, and it's what messes with our wireless systems. That distinction is going to be really important in a minute. So let's start with the absolute foundation of everything we do in IT, the electrical grid. We just kind of assume it's delivering clean, stable power all the time, but the reality? It can be a shockingly noisy and hostile place for our sensitive equipment. And here's the real irony. The biggest sources of this noise are often the very devices we install to manage and control power. Things like variable frequency drives for the building's HVAC, the UPS you have in your own server rooms, solar inverters, all of them work by switching power on and off at incredibly high speeds. And that process is just naturally, electrically, very noisy. Now here's the kicker. That electrical noise doesn't just stay inside the device. It actually gets pushed back out onto the building's wiring. This is that conducted EMI we just talked about. It basically pollutes the power for every single thing plugged into that circuit, from your main switches right down to your SAN. So, okay, dirty power can cause some network glitches. Annoying, but manageable. But let's really raise the stakes. What happens when this exact same issue pops up in a piece of critical infrastructure, like a municipal water treatment plant? All of a sudden, we're not talking about uptime anymore. We're talking about public health. Just picture this domino effect. A huge pump motor creates a burst of EMI that travels right down the power lines. That electrical noise gets into the control system and scrambles the readings from a super-sensitive sensor measuring, say, the chlorine level in the water. The automated system, which is now flying blind with bad data, makes a catastrophic decision. And the result is, well, it's bad. The system might underdose the water, failing to make it safe to drink. Or it could overdose, creating a chemical hazard and a massive regulatory headache. And it all started with an invisible electrical problem at the most basic physical layer. All right, now let's switch gears and go to one of the most electromagnetically chaotic places on the planet, a modern factory floor. This is where the big push for what we call Industry 4.0 is creating literally a perfect storm for interference. I mean, just let that sink in for a second. An arc welder isn't making a nice, clean signal on one frequency. It's like an electrical shotgun blast of noise across a huge part of the radio spectrum. It can easily disrupt Wi-Fi, Bluetooth, even cellular signals from way across the factory floor. Now, back in the day, this wasn't quite the disaster it is today. Old factories used hardwired networks, usually with thick, heavily shielded cables. Those systems were built like tanks, specifically designed to survive in that harsh electrical environment. But now, what are we doing? We're taking all these brand new, often delicate, wireless devices and just dropping them right into the middle of that same electrical firefight. We're trying to retrofit old buildings with new tech, and a lot of the time we're completely forgetting about this invisible threat. And listen, we're not talking about convenience gadgets here. We're talking about systems that are absolutely critical to the business. Wireless barcode scanners for inventory, Wi-Fi for tracking assets, IoT sensors that monitor the health of machines, even wireless emergency stop networks. When these things fail, production grinds to a halt, or even worse, someone's safety is put at risk. So this really brings us to a whole new area of responsibility for us in IT. When we're leading these big modernization projects, we can't treat the RF environment as an afterthought anymore. It has to be a primary design consideration, right up there with bandwidth needs and physical security. The report we're referencing makes a perfect analogy for this. If you've been around long enough to remember old Ethernet hubs, you know what a collision domain is. It's when two devices try to talk on the same wire at the same time, and the data just turns into garbage. Well, RFI is the exact same concept, but the collision isn't happening on a copper wire. It's happening in the air with radio waves. So, let's wrap this up. What are the big things to take away from all this? First, you've got to think beyond your server rack. The critical infrastructure your systems depend on is also a point of failure. Second, every time you replace a cable with a wireless signal, you're introducing a whole new set of physical layer risks you need to account for. And finally, the RF environment, the invisible world of radio waves, has to be a core part of your design process from day one. I'll just leave you with this final thought. We spend so much time and energy hardening our systems against digital attacks. But at the end of the day, our resilience is completely tied to the physical world. So the question is, how prepared is your team for the threats you can't even see?